Chapter 28 is about chi-square tests, and these are actually very useful. Other students have told me that they've used them a lot in other classes. So there are two chi-square tests that we're going to use. Number one, the chi-square test for goodness of fit. We use this one to determine if the occurrence of outcomes matches a specific distribution or a model. For example, a die is rolled 100 times with 6 possible outcomes. Is the die fair? And number two is the chi-square test for independence, and we use this to determine if two variables are independent, with independent meaning, of course, that they don't affect each other. So for example, we could answer a question like, is being left-handed independent of gender? So first, to use the chi-square test, you need to know how to use the chi-square distribution. So here are some examples of two chi-squared curves. The curves have long right-hand tails. Notice they are not symmetric. They are not bell-shaped. So in other words, they're nothing like the normal curve. That's okay. We can use other curves that don't look like the normal curve. There's nothing wrong with that. So first, let's talk about how the chi-square table is set up. This is a picture of the chi-square table. The chi-squared curve is affected by degrees of freedom, just like the t-curve. So down this left side, we have the degrees of freedom. Across the top, we have the area to the right. So it will always be the area to the right. So across the top is area to the right. And inside the actual table, so inside the table is the chi-squared values. So once again, it's set up like the t-table. So for this example, using the chi-squared table, let's practice finding some areas. So number one, let's find the area to the right of 9.24. So the chi-squared table is always, or curve is always right skewed. Let's say here's chi squared equals 9.24. We want the area to the right of it. We have 5 degrees of freedom. So we go to our chi-squared table, we have 5 degrees of freedom, so look at it with 5 degrees of freedom. Here's your 9.24. So the area to the right is 10%. Now number 2 says to the left of 9.24. So here's our same thing. We have chi squared equals 9.24, but we want the area to the left. Now our table doesn't give us areas to the left. There's no symmetry, so we can't find things with symmetry. But we can say if there's 10% to the right, then there's 100 minus 10, which equals 90% to the left. So my answer would be 90%. Now number 3, to the right of 0.55. So it's probably about here. We want the area to the right. Now we still have 5 degrees of freedom. So 5 degrees of freedom, here's my 0.55. So the area to the right is 99%. Now number 4, let's find the area to the right of 5. Now we have 7 degrees of freedom. So for 7 degrees of freedom, now we look at that row, and we were looking for a chi-squared of 5. And notice there is no 5 exactly, but 5 would be somewhere in here between 4.67 and 6.35. So the area is somewhere between 50 and 70%. And that's the best I can say just based on my table. And so my final answer is between 50% and 70%. And that's the best I can say with the table. Of course, I could use a calculator or computer to find that exactly. And number 5, let's find the area to the right of 2.5. Actually, let's change that. Let's find the area to the right of chi squared equals 15. So here's chi-squared equals 15. We want to find the area to the right. We have 4 degrees of freedom. So 4 degrees of freedom, we're looking for 15. Notice 15 is going to be somewhere off here, so the area is going to be somewhere off here. So what we're going to say is that the area is less than 1%.